All right, so let's just go over the 5 basic examples of antiderivative rules. And remember, throughout antiderivatives or indefinite integrals, we want to think about how we are adding things on. So when we take, for example, the derivative of 3, it becomes 0. But when we take the antiderivative, because we're going backwards, the antiderivative or integral of 3 doesn't become 0. What's going to happen is it becomes a 3x plus c. Now, you might ask where that is coming from. To get that, we're actually using the power rule. So the power rule, if I have x dx, for example, again, we have x to the first, and the power rule says that we'll do 2 things. The first thing is we're going to add 1 to the exponent, and then we divide by the new exponent. Now, you'll notice that as soon as I apply this rule of adding 1 to the exponent and dividing by the new exponent, that is when I am going to lose this notation of integral dx. So over here, when I start to add 1 to the exponent and divide by the new exponent, I'm no longer going to write the integral dx. I'm just going to have x to the second and then divide by the new exponent of 2. And when I lose the integral dx, because there are not bounds on this integral, we add a plus c. And that plus c again is because there are no bounds, and that means we have what we call an indefinite integral. So over here with our 3dx, really what's happening is you have 3x to the 0 dx. And so if you apply the power rule to x to the 0, you will have 3x to the first, adding 1 to the exponent, and then dividing by the new exponent, which of course will just give us 3x plus c. Okay, so that's our first big rule, is this power rule here, where we add 1 to the exponent, divide by the new exponent. And there are several variations on this theme of using the power rule. One thing you want to be careful of is when you have a fraction. So if, for example, I have something that looks like x to the 2/5 dx, what will happen there is I will add 1 to the exponent. And again, as soon as I add 1 to the exponent, I lose this whole integral sign. So I take my little 2/5 and I add 1. So to add 1, I want to write that as 5 over 5. So that becomes 7/5. So adding 1 to the exponent is really going to result in an exponent of 7/5. Now, step 2 of the power rule is to divide by the new exponent. So we divide by 7/5, and then we add our plus c. And we're adding the plus c here because there are not bounds on the integral. Now, you cannot leave your answer like this because you have this fraction in the denominator. And whenever you have the fraction in the denominator, what you will do is you will flip it because you're going to multiply by the reciprocal of the denominator. So to reduce this, I will flip the 7/5 to become 5 over 7 x to the 7/5 plus c. And that is our answer for what we're saying that the integral of x to the 2/5 dx is equal to. Now, 2 other examples of this will be when we have 1 over x and e to the 3x. And we'll actually do that on the next video. So these are just some examples of our power rule that we have.